Have you ever wanted a battery pack that's going to last all day and not cost an arm and a leg? Well, stay tuned because I've got something for you. Hi, I'm Matthew from Video Scene, and today I'm going to go through with you my battery solution. Originally I looked at getting a vmount battery to power remote cameras, and when I looked at the price I thought, wow, we're looking at a battery that will last all day, but it's going to cost around about 500 New Zealand dollars. And when I looked around and to see what was available, I came up with a solution that would cost about 20% of that, about $100 New Zealand, and get the same, if not better, output. So let's have a look at it. This is the finished product, and let's break it down into the bits and pieces that we've used. I've used Sony MPF batteries, which can be bought on Amazon or AliExpress. I've used battery mount adapter plates, and I've used a little voltage converter called from RC None, which I purchased from AliExpress. For all these different items, I'll try and put a link in the bottom so that you can go there using my affiliate link and support the channel, and at the same time get the right product. So why did I do this? The reason being, as I said to you before, I wanted a remote camera that I could run all day, and I could run other things with that camera. Now, because I use prosumer or consumer cameras, they have an HDMI output, and I have to convert that HDMI output into SDI for the professional video equipment that I use. So I use the decimator. Again, there'll be a link down below so you can go and get yourself one, and the decimator will output SDI, so I only need one cable on my remote cameras. As you can see in the circuit diagram, the batteries are connected in series. The batteries I'm using for this experiment are 7.4 volt Sony compatible MPF batteries, and these ones are 8.5 amps or 8,500 milliamp hours. Now I'll just show you a bit of a diagram as to how that looks. We have two 7.4 volt batteries, which leaves us 14.8 volts because we're going to connect those in series. Now let's have a look at the amperage. Now, because we're connecting them in series, the amperage over the batteries won't change. The wattage will be the same as well, but the amperage itself won't change because they're in series. However, once we actually convert that down to 5 volt, that will change. So what we've got, 7.4 volts times 2 is 14.8 volts. At 8.5 amps, that gives us wattage using Ohm's law of 125.8 watts. Okay, now we're going to convert that back to 5 volts. So our 5 volt at 125 watts gives us a usable battery of 25.16 amps. Or let's just say 25 amps for the sake of this. Now, the devices that I'm using that are connected to this are using approximately 1 amp per hour or 1 amp hour to run those various devices. Now, based on 1 amp hour, effectively I could run these devices for 25 hours. So that's 2 days worth of filming, or if we split that into 8-hour days, that's 3 days worth of filming on one set of batteries. So what we're going to do now is put it all together. First, we're going to take the two battery plates and we're going to unscrew the 4 screws on each of the adapters. Now, what we're going to do is also take off the wires that connect to the battery contacts, and we're going to mark each of those contacts positive and negative, or if you prefer, just mark the positive ones, because the other one, there's only 2, so the other one will be negative. Alright, now what we need to do is take a length of wire about 10 centimeters long or 100 millimeters long, and we need to make a connection between the positive on one battery plate and the negative on the other battery plate. Great. So once that's done, we can then mount the RC none, or the converter, the voltage converter, into a box. Now I've just used one that I've picked up at the local electronics shop, but I'm sure they're available on the web if you have a look around. It just needs to be big enough so that it can fit the voltage converter inside it. Okay, so once you've got the voltage converter inside it, you'll need to put a hole in the end of that box so that you can feed out the wires that need to go to the battery plates. Those will be the input wires, the positive and the negative. Now on each of the battery plates you'll have a positive and a negative that aren't used. So take the red wire, put it to the positive, and then the black wire, put it to the negative on the other battery plate. Okay, so now you'll have a battery plate that's connected in series to the device. Now it's really a simple process of mounting those battery plates onto the box. I've just used a hot glue gun, but you may want to use epoxy resin or some other contact adhesive. Even using double-sided sticky tape probably will work. As I say, I've used a hot glue gun to make that connection. Now, so what we've got is we've got two battery plates mounted on a box with USB outlets on it. Now there's no switch because there's no need to. The circuit is not active until two batteries have been installed. If you put one battery on it, it will not work. It needs to have two because it needs two batteries for the circuit to be complete. So as soon as you disconnect one battery, you're turning the unit off. Okay, so now you have a battery unit which will allow you to run your devices all day, and it's only cost you about $100 in small parts. Thanks for watching, and if you've got any ideas that could help improve this design, please feel free to put a comment below. Don't forget to like and subscribe to the channel, and keep your eye out for upcoming videos. I'm Matthew, this is Video Scene. Thanks for watching.